All right, guys. So we're gonna finish up 4 5 uh, this weekend. So it was a two-part lesson. So let's take a look at number 9. Given AB is congruent to CD. So AB and CD are congruent. AB, those two lines mean parallel. So AB is parallel to CD. Okay, so they're parallel. And D is the midpoint of BE. So if it's the midpoint, what does that mean? It means it cuts BE in half. So BD and DE are congruent. Okay, so number 1. What's our given? So our statement AB is congruent to CD. How do we know that? That's given. All right, then we would have AB is parallel to CD, given. All right, and then the last one, D is the midpoint of BE, and that's also given. All right, so now what are we trying to prove? So our last one, our prove triangle ABD is congruent to triangle CDE. All right, so let's just talk. We have 4 and 5 that we have to fill in. How did we know that BD is congruent to DE? So we could say BD is congruent to ED by what reasoning? Since D was the midpoint of that line, that is the definition of midpoint. All right. Now, we're missing number 5. We have a side and a side. What can we say about this angle? Angle B and angle D. Since they are parallel lines, angle B is congruent to angle D by what way? What type of angles are they if they are on the same location of two different parallel lines? They are corresponding angles. All right, corresponding angles. So now what is our reasoning for the triangles? Side, angle, side, side, angle, side. SAS. All right. Number 10, given. So KM is congruent to NM. All right, I'm going to write that. KM congruent NM. Given. LK is congruent to LN. Given. So LK and LN. All right, what are we trying to prove? Because we don't have any more givens. Triangle LKM is congruent to triangle LNM. All right, so let's talk about what part are we missing? We're missing anything with an angle. Do we really have anything that says K is equal to N? No, but what can we say about the line LM? It can be congruent to what? Itself. ML. What was that property? Reflexive. All right. And so now what is our reasoning? Side, 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 side. S, S, S. All right. Number 11. AD is congruent to AB. Oh, they already marked it for us. That's nice. So AD congruent AB, given. And what does this say? AC bisects angle DAB. Okay, what does bisect mean? It means it cuts it in half. So angle, or AB, cuts DAB in half. So therefore that angle and that angle are now the same because it cuts it in half. So what could we say? Angle DAC, because it cuts it in half, is congruent to angle what? BAC. By what reasoning? Definition of what? Definition of angle bisector. What are we trying to prove? I forgot to do that. Triangle ADC is congruent to triangle ABC. So what's our 4? We can't have side angle. We need something about this side. What do we know about AC? AC can be equal to CA. They are reflexive. They can be the same. Okay? It can be reflexive. So now what is our reasoning? Side, angle, side. SAS. All right? Let's skip down to using SSS in the coordinate plane. All right. So we're just going to do one of these. We're just going to do number 1. All right? I'm going to do both of them. Don't need to. So let's take a look at number 1. Given the coordinates, determine if they are congruent. All right, so what we have to do, PQ, we have to use the distance formula. So remember the distance formula, x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared, right? So PQ, so square root, what is x sub 1? So 5 minus x sub 2, negative 3 squared, plus y, negative 4 minus 7 squared. Add here. So 5 plus 3 is 8 squared. So square root 8 squared plus negative 11 squared. So square root 8 squared is 64 plus negative 11 squared, 121. Add those together. Square root 185. All right. So that's PQ. Now let's do QR. So same thing. Square root Q. So the x of Q, so negative 3 minus the x of R, which is 0 squared, plus the y of Q, 7 minus the y of R, 2 squared. All right, so square root negative 3 minus 0, well, that's obviously just negative 3 squared, plus 7 minus 2, 5 squared. Negative 3 squared is 9, plus 5 squared, which is 25. Add those together, square root 34. Okay. Now we go to PR. Okay, so square root P. So 5 minus the x of R, which is 0, squared, plus negative 4 minus 2 squared. All right, so negative 5 minus 0, that's obviously, or 5 minus 0, which is 5 squared, plus negative 6 squared. Negative 5, or 5 squared is 25, plus negative 6 squared, which is 36. Add those together, square root 61. All right, now we have to do the other triangle. So now xy, so same thing, square root, what is the x of x? So negative 2 minus 9 squared plus negative 1 minus 7 squared. So square root, negative 2 minus 9 is negative 11 squared, plus negative 1 minus 7, which is negative 8 squared. Negative 11 squared is 121. Negative 8 squared is 64. Add those together. Square root 185. Okay. Let's go to YZ. So square root the x of y, so 9 minus the x of z, which is 3 squared, plus 7 minus 2 squared. 9 minus 3 is 6. 6 squared, plus 7 minus 2, which is 5 squared. 36 plus 25 square root 61. And now for xz, square root, x is so negative 2 minus 3 squared, plus negative 1 minus 2 squared. So negative 2 minus 3 is negative 5. Negative 5 squared, plus negative 3 squared. Negative 5 minus or squared is 25, plus negative 3 squared, which is 9, comes out to square root 34. So let's see. 185s, yes, I have a match to here. Square root of 34s, I have a match. Square root of 61s, I have a match. Since I have a match in all three of them, are they congruent? Yes. By side, side, side. If you don't have all matches, then they would not be congruent. All right, there you go.